Okay, in this video we're going to actually do some operations with radical expressions via addition and subtraction. Some of the points that I want you to know about addition and subtraction of radical expressions is what do we mean by a like radical? So a like radical, you see here the word like radical, those are expressions that have the same index and the same radicand. And as you know, radicand is what's inside the radical sign. So for example, when you go down here to the first example, 12 square root of x minus 6 square root of x, both of these terms are like radicals because they both are square roots, right? So the index is 2 for both. Remember, again, when they don't write the little number here, the index, it's understood to be 2 because that's a square root. And the radicand for both of these is x. So radicand is x. So they have the same index. They're both square roots and they're both square roots of x. So then to subtract these, we're going to subtract them just the way we subtract like terms that don't have radicals. For example, 12x minus 6x would be 6x, right? So 12 square root of x minus 6 square root of x is equal to 6 square root of x. So you're going to keep the radical part and you're going to work with the numbers in front, right? The coefficients. So 12 minus 6, 6 radical x. Okay, so not too bad, right? So let's look at this next one, example 2. Here you have 3 terms. They are all 3 terms are like radicals because they have square roots. They're all square roots, so index is 2. And also because the radicand is 2. So radicand is 2. So again, these are all like radicals. So we're going to work with those coefficients. So 2 minus 19 is a negative 17 plus a 9. So 2 radical 2 minus 19 radical 2 is a negative 17 square root of 2 plus 9 square root of 2, and then add a negative 17 and a positive 9, and you get a negative 8 square root of 2. So that's your answer. Okay, so now we're going to go to number 3. And in number 3, when you first look at the problem, they do not look like they're like radicals. They're both square roots. So you have a square root of, you do have the square root of 3, but here you have the square root of 27. So they're both square roots, but the radicands are different. So instead, before we give up on this problem, we are going to simplify the radicals. So by that I mean that the square root of 27, there's a perfect square in here. And if you recall from previous work, we can do a little factor tree here. And so 27 is 9 times 3, and 9 is 3 times 3. So the square root of 27, you have 3 times 3 times 3. And if you recall from previous work, we're going to be looking for groups of 2 common factors because our index is 2. So when the index is 2, we look for 2 common factors. And so this is the square root of 9 or the square root of 3 squared, which is 3. So for every 2 common factors under the radical, you are able to bring out of the radical 3 because that is the square root of 3 squared. So square root of 27 is 3 square root of 3. Okay, so we're going to replace the square root of 27 here with 3 square root of 3 and then multiply the 7 and the 3 and get 21 square root of 3. And now, and I'm bringing down the negative 3 square root of 3. Now you can see that these 2 terms are like terms, right? They're like radicals. So we can work with the coefficients, which is the negative 3 added to the positive 21, and that gives us an 18 square root of 3. Let's look at number 4. So now we have 3 terms. They do not look like they're like radicals, but we can tell from the radicand 75, square root of 75, square root of 12, and square root of 48, we can tell that there's some perfect squares in there. These can be simplified. So that's what we're going to do first. So simplify, then we're going to come over here. So square root of 75. So this is 25 times 3. And 25 is a perfect square. It's 5 times 5. So there's our 2 common factors. And then we have this single 3. So we're going to pull out the 5. So square root of 25 is 5. And then we have the 3 that stays inside the radical. So here we have the original 3, the 5 that we took out of the square root because we had two 5s, square root of 25, and then the extra 3 that was left behind for the 75, right? So this is 15 root 3. Square root of 12. Square root of 12 is 4 times 3. Square root of 4, square root of 3. So 2 square root of 3. And so here we're going to take, this is a negative 2 times a 2 square root of 3. Right? We replace the 12 with that. So this is a negative 4 square root of 3. So these two are definitely like terms, aren't they? Okay. And now I have square root of 48. So square root of 48. Well, let's see. That's definitely 6 times 8, isn't it? And that's a 2 times 3. And that's a 2 times 4. And that's a 2 times 2. So we have 2 2's here. And then 2 2's there. And the extra 3, right? So then this is going to be equal to 4 square root of 3. So remember, we took 1 2 out from this square root and 1 2 out from this square root and 1 2 out from this square root, and that gives us the 4, and the 3 is extra. Here we have plus, so here we have 2 times 4 square root of 3, and this is 8 square root of 3. Okay, so 15 square root of 3 minus 4 square root of 3 plus 8 square root of 3 is equal to, so 15 minus 4 is 11, and 11 plus 8 is 19 square root of 3. 12 square root, so do we have negative 4 times the square root of 12x. And we've done 12 before. That was the 4 times 3, remember? So we need to take the square root of 4, which is a 2, and then we're going to multiply that times the negative 4. So negative 8 square root of 3, and then this x. Don't forget the x. And then here we have the 75 again. We did that previously, didn't we? So we have minus 5 square root of 75x. So that's 25 times 3x. Square root of 25 is 5, which we multiply times this 5. So negative 25, and then another square root of 3x. Like radicals, so we get negative 33 square root of 3x. We have here negative 6 square root of 18t to the third minus 10t square root of 50t. The 18 is 9 times 2. That's a perfect square, the 9. So we take the square root of that. And the t cubed, there's 3 t's here, right? And we need groups of 2 t's. So there's 1. The square root of 9t squared is 3t, which is going to get multiplied times the negative 6. So that's a negative 18t. Then put your square root. And what's left over? What's left over? Well, this square root of 2 is still here, and this extra t. So that goes in the radical. All right. And then over here, 50t. 50 is 25 times 2. We only have one single t here, so that's okay. But here's your perfect square, right? Which is 25. And so that's square root is 5. We're going to multiply times the 10t minus, the minus was in the original problem, right? 5 times 10t is 50t square root of 2t. And now these are like terms, right? Because they are both t square root 2t. See that? So the radicals are like radicals, but also you need to have the t's, the outside t's match, right? So we can add the negative 18 with the negative 50, so negative 68t square root 2t.